You're sort of the planetary man in charge here at NASA headquarters, is that correct?
Yeah, you could look at it that way. Indeed, my job is to be the top advocate for planetary science in the federal government.
Well, we've been wondering what kind of science do you think we'll get from this very rare, in our case, event every 100 years or so?
Yeah, I mean, it's last time anyone on this earth will be able to have an opportunity to look at this fabulous event. And so from a scientific point of view, we have developed a variety of instruments that will be trained on this transit. In particular, there's a point where Venus, as it just gets nearly completely on the disk, where the sunlight shines through the atmosphere and provides us a great spectrum of not only the solar spectrum, but what's going on in the Venus atmosphere. And that's very unique. It's important to make those observations. It's important that we compare them with what we think we should see. And you never can tell. There might be some big surprises.
So it's not just a historical event. We actually may get some key science from it.
Oh, absolutely. And in fact, it's one of those things that you never can tell what will come out of it. But one of the really exciting things about this is we're understanding that planets exist around other stars. They also go through this transit mechanism. Kepler sees many of these transiting planets. And so we want to look at the atmospheres of those planets too. And so by looking at Venus in the right way within our own system, it sort of gives us a Rosetta Stone of what we might see when we look at other planets around other stars.
You're looking at a lot of these objects in our solar system, and the idea is the more we learn about this solar system, it's going to make it much more easy, along with what we learned from Kepler, how to actually move out of our solar system.
Yeah, indeed. The more we learn about our solar system, the more we understand how other solar systems should look like around other stars. And what we're finding is they look very different. We have planets like Jupiter around other stars that are as close to their sun as Mercury is to our sun. So how did this huge planet get inward? And this actually has caused us to start thinking about the dynamics, the gravitational dynamics that go on that push planets around within solar systems and what might have happened to our own over time because of our large planets and their interactions gravitationally.
Yeah, I'm sitting here thinking, what would a Venus transit look like if Venus was the size of Jupiter? I mean, we might be in a really bad situation in terms of
Well, if we had a Jupiter there and it formed there originally, we probably would not have a planet called Earth.
Oh, wow.
And the reason why is the gravitational interaction with Jupiter is so disruptive, we would have a very hard time accumulating the material necessary to form a planet. Now here's how we know that. Jupiter has already done that to our own objects in our solar system. There's a huge region called the asteroid belt that exists between Mars and Jupiter, and it's actually a set of material that's trying to come together to form a planet. But Jupiter's gravity won't let it. It keeps tugging and pulling and keeping it apart.
I've always been suspicious of Jupiter. I'm sorry. I mean, I just think that's really unfortunate.
Okay, but Jupiter's a good guy.
Okay.
He's a really good guy, and here's why. Here's why.
Okay.
There's a lot of material we're finding out, not only in the Kuiper Belt, but in very distant regions, cometary material at the very fringe of the gravity of our sun. And sometimes that material comes in, and when they do, they're going to come in and hit the biggest target, and that's Jupiter. And so we believe Jupiter has been a big brother to us, and it's really protected life on this planet and allowed us to flourish. The only way we know about these is actually get out and visit Jupiter, go to the asteroid belt. We have a huge spacecraft called Dawn with very big solar panels and ion engines, is currently orbiting Vesta, and it's done its mission now, and it's on its way out, and it will go to another asteroid called Ceres. And then we'll learn more about what's in the asteroid belt. And then we have another spacecraft called Cassini, and it is orbiting Saturn.
I feel like I need to have my notepad out.
You should, because that mission is looking at objects, moons like Enceladus, little bitty moons that are just absolutely turning itself inside out, spraying water in that whole area, and then bigger moons like Titan.
Yeah.
And Titan has this enormous atmosphere, and in fact Titan is bigger than the planet Mercury. Wow. Okay, and if we were to take Titan and pull it out of the gravitational influence of Saturn and put it around the sun, we'd call it a planet.
Wow. Well, that's how you're going to have to readjust the whole planetary system. But I guess it does. It's fixed moon. It can't be a planet yet, right?
Correct.
Right?
Correct.
Yeah, so,
correct.
Right. So I have to relearn the planets. That's one thing I'm very concerned about being over 40.
Okay. Well, you might have to do that because we're on the road to discovering major things. That's all in our future.